Recording. Okay. So I didn't print quite enough assignments. So just, if you didn't get one, I'm counting, I think, 4 that I need to run upstairs and print. I'll just go upstairs, make a photocopy, and you'll have a copy of the assignment, so don't worry. Just a couple of notes about the assignment. So whenever I give you an assignment, you'll always have a week to do it, unless it's like one question, which won't happen. So you have a week to do it, and it's due at the beginning of class next Wednesday. Okay. By the end of today, you'll be able to do all of it. Okay. You'll see there's some stuff on here that we haven't covered yet, but of course, we're going to cover that today. Okay. It's only out of 19. Got the little how much each question is worth. All right, so just kind of quick little answers for a lot of it. Well, maybe not the calculations, but oh, I did add something new. So if you have taken a course with me before, I've often said, you know, if you can't get your assignment in, just email it to me. I still want you to do that. So it's due at the beginning of class. I don't accept any late assignments. You have a week to do it. I see no reason for late assignments. You can get me a copy somehow. You can figure it out. You've got the tools. You've got what you need, okay? However, this term, I'm only gonna mark hard copies, okay? So if you're not coming to class or whatever, then yeah, send me pictures of your completed assignment. Make sure that I can make sure that it's completed on time, right? And then get me the hard copy as soon as you can, okay? Ideally, if you know you're not coming to class, maybe hand it in early. I don't know, how's that for a wild idea, okay? So you can always slip it under my door, C184 or C104, 184 is the lab, C104, right? So just slip it under the door, even if it's closed. You don't have to physically hand it to me, right? But you have to get me the hard copy so I can mark it. Okay? Otherwise, things get lost, and you don't get any feedback when I mark it by email. So that's kind of new this term. So you're going to do all your work on here. That's why I give you the printed copies. Okay? So you're going to do all your work on here and hand it in. Okay? And if I can't read what you've done, that's a problem, right? And so I can't give you marks if I don't understand what's going on. If it's so messy, so unclear, then I'll have to take some marks off, okay? Which you can't really afford when it's only out of 19, right? Even if it's just half a mark, that's a kind of a big deal, right? So any questions about the assignment? No. So like I said, I didn't print quite enough just because I didn't want to be lugging all kinds of paper around, but after class, I'll run upstairs, just kind of get a count of how many I need, and then follow me upstairs. Can print copies, okay? All right, bless you. Any questions before we get started? Well, so first assignment, fun. How much have we learned so far? Quite a bit, actually, quite a bit. So just a quick review. It was just on Monday that we met, so I'll just do a quick little run through, right? And then we'll keep going. And I'm hoping to finish chapter 1 today. Okay? So, quick review. We talked about how do we describe a distribution, right? We said we have to talk about the shape, the center, and the spread, right? So describe or describing distributions. We talked about how do we find the mean? What is the mean? The mean's the average, right? And we also introduced sigma notation, right? Or summation notation. Fun to say, fun to do. right? So finding the mean. And we introduced that example, which we'll use again today. Just keep going with those same numbers. So we talked about finding the mean and finding the standard deviation. And then we talked about how do we make a quick visualization. If we had to just quickly do it by hand, we're going to use a stem and leaf plot. So a stem and leaf plot, or stem and leaf plots to quickly visualize data. So if you're flipping through the assignment, right, question 1 is kind of a lot of, dealing with variables. What type of variable is this? What type of study is this? Just very brief. People get tripped up on this question because they feel like they need to say more than they have. Probably not, right? So very just brief answers. And for part E, anything goes, okay? I just want to know how you would do it, right? So try to come up with some way that you would sample 40 students, I think it is, okay? Just any way that you can think of, briefly describe it. It doesn't have to be a big deal, right? I'm just curious to know how you would do it, right? So there's no right or wrong answer. Just kind of say, I would do this because of this, right? Okay. And then for question 2, I've given you 2 data sets, very similar to the example that we've been working through, right? And we'll talk about the 5-number summaries and the outliers. And then part E, find the mean, which we did last day. And then F is just comparing the mean and the median. And then G, find the standard deviation, right? So you can do a good chunk of this assignment already, even before today. So, any questions before we get started? So very brief review, because it was just on Monday that we met. So, okay, so recall the example. Let's see how I worded it. Oh, I'll print you a copy after class. Yeah, I didn't print enough, that's why. The distance flown in a day by 9 parrots. Of course, you probably have this in your notes, but just so we have a refresher, is recorded below. Yeah, 1.6 is a biggie. So in kilometers, and then we said, I changed the numbers. So we had 2.8, 1.3 kilometers, one lazy little parrot only flew half a kilometer, 4.7, 3.5, 7.1, 1.9, 2.1, and 3.4. I always just double check that I have 9, just so I didn't skip any. 1, 2, 3, 4, 5, 6, 7, 8, 9. Great. So those are the same numbers that we had last day. Can't remember, did I make a stem and leaf part or stem and leaf plot apart? Was it part C, or I'll just flip back briefly. I don't think so. I just snuck it in there. Sneaky. It's probably good. Then I can keep my lettering the same. So part C, right? So A was find the mean, B was find the standard deviation, and then probably another part should have been find the stem and leaf plot, but I wasn't quite on it. And so now I would say find the median distance flown. We have to know what the median is, right? And so, and that's why I like to set it up this way, right? Give you an example, some numbers, and then give you the questions, because it kind of guides us, you know, what is the median, right? If we have to find it, we have to know what it is. And then when you're going back to it, they're all in the same place. Okay. So the median is going to be the value that splits our data in half, meaning we have the lowest 50% below it and the highest 50% above it. Right? To get that, right, we first have to sort our data. Right? And so first we sort our data from smallest to largest, or largest to smallest if you like, but I won't, doesn't matter. But from smallest to largest is what I'll do, right? So you have to sort your data, and then we're gonna find the data point in the center, right? And that's your median. Okay? So the median is the value that splits your data in half. So the smallest 50% of data points are below it. And of course, the largest 50% of data points are above it. So there's some steps, right? First we have to sort it, and then we have to find the center. Okay, so to find the median, the first step is very important. Right? Sort your data from smallest to largest. Here's where I deviate from any sort of textbook. So a textbook will give you this kind of nasty formula for finding the position of the median, when in reality, right, we're gonna have all these tiny data sets, right? This is very tiny, 9 data points, right? And so let's pretend that this has been sorted already. Right? We would guess that the data point somewhere around here, right? But I like to just do the boop, boop, boop method. Patent pending. No, kidding. But I just call it the boop, boop, boop method because I just take my fingers and I just start at the end and then I boop, 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 boop. You just boop your way in. It's the easiest. You don't have to deal with formulas that tell you the position of the median and then you have to find it. It's just easier to just boop, 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 boop your way in. Okay? So it's pretty fun. So I'm just going to say use the boop, boop, boop method to find the central value. So let's do it. So we're going to first sort our data, right? And so I've got, so I'll just say sort here. So we've got, I think our smallest is 0.5. And as I go, I like to kind of cross these off. Maybe I'll sneak these down a bit so I don't have to keep scrolling. So I like to cross them off as I go, or put a little check mark or whatever. After 0.5, I've got 1.3, 1.9, 2.1, 2.8, 3.4, 3.5, and then 4.7 and 7.1. Again, just count all these values. Make sure that you still have 9. Pretty common mistake. I know it seems silly because we're crossing them off and stuff, but pretty common that one goes missing and you don't notice. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So now, right, just take your fingers. You do go a little bit cross-eyed, but boop, boop, boop. I did it. Boop, 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 boop. So I'm landing on 2.8 is the center value. Okay. What would it look like if we didn't have, let's say, the 7.1? Right, so now we only have 8 data points. Right, so then we would start at 0.5 and 4.7 and boop, boop, boop. Right, we land on these 2 at the same time. What you're going to do if you land on 2 values at the same time, you're going to circle the 2, and then the median actually ends up between the 2, and it's going to be the average of the 2. Confusing. The median is going to be the mean of the 2 central values, but that's just how it is. And so I'll make a note here. If we had 8 data points, right, just as a quick, I'll just copy this here. So imagine you had something like this, right? So then we decided, okay, boop, boop. So then we would draw it like this to indicate that I'm taking the average of these 2 values, right? These 2 values are in the middle, but actually between the 2 is the median. Okay. So here, the median is 2.1 plus 2.8 divided by 2, which I don't do math in my head, and that's okay. 2.45. Okay. Right, so here, the median was 2.8. And then if we had 8 data points, it would shift it slightly, right, to 2.45. Okay. So depending on if you have an odd number or an even number of data points, right, then how you find the median is going to change. Okay. So there, the 2 examples of finding the median. Okay. You'll notice on question 2, right, I've given you 1 odd number of data points and 1 even number of data points. I wonder why that is. So you can show me that you know how to deal with both. Okay. So that's the median. Okay. And we already know that we should use the median if we have a non-normal distribution. Okay. We can find the median for a normal distribution as well, right? But the reason that we prefer the median over the mean for a non-normal distribution is because the median is not as influenced by outliers, right? So it's not, or it is, I'll say, it is resistant to outliers, right? Or extreme values. Whereas the mean, the average, right? Think about this. Here we removed a pretty large point, right? Let's make it drastic and change it to 71. All of a sudden there's some here that was 71 kilometers. Who knows, right? The average of these numbers would be pretty large, right? Just because of that 71. Right? Whereas here, if we just remove the data point 71, then we've got this kind of reasonable average, right? So the median, it doesn't matter if this is 7.1 or 71 or 700, right? It doesn't matter the size of this value, right? The median only cares about the number of data points, right? And then where's the middle? So the median is resistant to outliers. So make a note of that. We use the median. I'll throw in and the interquartile range. Remember, that's the measure of spread for a non-normal distribution that we use. And so we'll get to that, right? But I'll just throw it in here because it applies to both. And the interquartile range, IQR. For non-normal distributions, because they are resistant to outliers. They are resistant to outliers. Whereas the mean gets pulled in the direction of the tail, right? It's going to be pulled in the direction of any extreme values. So whereas the mean gets pulled towards extreme values, I'll put in brackets, in the direction of the tail. So just to have a little visual here, bless you. Right, let's say we have this skewed distribution, right? This is skewed to the right, right? It's always skewed in the direction of the tail. Right? And so the median, the central value, it would be where we would put kind of the peak of the lump here still. Right, so this would be the median. But just to make it kind of extreme, the mean would get pulled in the direction of the tail, right? So it's not really a good measure of center anymore. What if we have something like a normal distribution? If we have a normal distribution, then, right, it's symmetric around the middle. And so then the mean is going to be in the center, right? And the median would be in the center, right? So here, the median will be roughly equal to the mean. So that's a quick way to check if you might have a normal distribution if you can't visualize it, right? Is check the mean and check the median. If they're close, right? They're not going to be exactly the same, but if they're close, then odds are you have a normal distribution, right? And there's a question on that on your assignment. I think it's F, 2F. Any questions so far? Okay. So part D, or our pretend part D, if I ask you to find the interquartile range of distances flown. So remember the median splits our data in half, right? The interquartile range, you might have even guessed it, right? We have to split our data into quarters. And then the interquartile range, inter means between, right? Quartile. So between the quartile range, you're going between the first and the third quartile. And so the interquartile range, so the IQR, I'll write it out here just once again, and then interquartile range is the distance between the first quartile and the third quartile. This means we need to split our data into quarters, right? We need to split our data into quarters. So we use this notation. So capital Q subscript 1, right? So a little subscript 1 is the first quartile. So it splits the data with the lowest 25%, right? The lowest quarter below it, with the lowest 25% below it, and highest, of course, 75% above it. First quarter. Second quarter is the median, right? If you got 2 quarters, you've got half the data, right? So we've already found the second quartile. We just call it the median instead. So Q2, so Q subscript 2 is the second quartile. Which is the median. Oops. Drop it here. Right. 50% below, 50% above. Oh, we already talked about that one. Third quartile, Q3, third quartile, it splits the data, and you probably could just fill in the blanks, right? With the lowest 75% below it and the highest 25% above it. So splits the data with, oh, I like to convert or merge with the for some reason, just becomes with, with the lowest 75% below it and highest 25% above it. You're first going to find the median, and then from the median, right, we just kind of scroll up here. From the median, if you had to split this into quarters instead, right, you cut it in half, and then we can just use the same method again. We can just use the boop, boop, boop method to find the quartiles, right? You're going to cut this in half, right? This region in half, and then you're going to cut this region in half. Notice one thing here is that here we've used this 2.8. Okay? So you're not going to use it to find your quartiles, right? So your booping is going to start from here and from here on either side because you've already used this 2.8. The difference here is that we didn't actually use either of these values, right? The median we decided was at this line. So how you're going to find your quartiles is going to be slightly different, right? Because here is your median, which means you're going to start your booping here at 2.1, move your way in, right? And 2.8, move your way in. I'll show you both examples, right? But that's the logic. So if you've used the value, then it's out. You can't use it again to find your quartiles. But if you just took the average of two values, then the median is technically in the middle there somewhere, right? So you haven't used them. Okay. Let's see if I can, I'll just copy all of these. They're probably not that far away on your page, but on mine, it's a lot of scrolling. Okay. Yeah, I'll just paste it. Okay. I'll just say, recall this. So change colors just for some new stuff here. So we'll find the quartiles and then we'll make some notes about it. So just because we've already talked about it. Right, so here 2.8's been used up, so we're going to start at 2.1 and then 0.5. Here, right, we're just going to take the average of these two numbers and that's the first quartile. same idea, right? Here, boop in once, the average of those two numbers. Whereas here, right, for 8 data points, this is the median, so you're going to start at 2.1 and then boop, 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 boop. Yes, still the average of 1.3 and 1.9. And then here you're going to do 2.8 from 4.7. Boop, boop. So now it's the average of 3.4 and 3.5 instead of 3.5 and 4.7. So boop, boop. So you can say Q1 is 1.3 plus 1.9 divided by 2. $1.6. And then same on this side. Q3 is 3.5 plus 4.7 divided by 2. We'll just quickly do this other one too. Boop, boop. I'll show the same math here. The only one that changes is Q3. So boop, boop. Q3 is 3.4 plus 3.5 divided by 2. Even I can do that one. Let's make some notes about finding the quartiles. So finding the quartiles, right? If you've used the value as the median, right? Remember we have two kind of situations. So if you have used a value for the median, see first example above, we don't include it in finding the quartiles. Include it in finding the quartiles. But then you're gonna just use the boop, boop, boop method. I'll just say boop method. Don't have to. Or how about boop to the power of 3? Catchy. Boop, boop, boop. Use boop, the boop, boop, boop method. To split the lowest 50% of data in half. I guess to find Q1. And then same thing, right? You're gonna do it for the highest 50% to split it in half. and then use feeling pretty clever about my boop to the power of 3. The boop, boop, boop method. To split the highest 50% of data in half to find Q3. The only difference, right, in finding these quartiles, and I don't like to write out all these rules. They're good to have to refer to, right? But if you know how to do it, that's the end game, right? So if when we did it together, it made sense, then that's great. You don't have to go home and memorize these steps, right? Because I'm just writing out exactly what we're doing. Okay? So if you found the median by taking the average of 2 values, if you found the median by taking the average of 2 values, we use them in finding the quartiles. We use the value, I'll say the value on either side of the line, right, that we drew as our median. We use the values or the value on either side of the line which is the median, to find our quartiles. Right, and then just repeat steps above. It just depends on how did you find your median, which values can we use, which values do we not use. Any questions so far? No. Remember, the whole goal was to find the interquartile range. We might have guessed that it's the distance between Q1 and Q3. It is, right? So to find the interquartile range, is Q3 minus Q1. Right? Q3 is always going to be larger than Q1, right? So to find the distance between the two, we have to take Q3 minus Q1. Right, because it's the distance between the two. Right. I'll just say the distance between Q1 and Q3. I'll steal these guys again. Oops. And of course you have them on your page, so don't have to. But here, let's do a lighter blue. All right. Let's call this 9 data points. And then this we'll refer to as 8 data points. So the interquartile range with 9 data points. Q3 minus Q1 4.1 minus 1.6. 2.5. So this is what we would use as our measure of spread, right? And we use the interquartile range. We could use any value. I like to use the interquartile range, right? Anything to do with the quartiles we can use for the spread for a non-normal distribution. But it just gives an idea of the spread of the central 50% of values, right? So that's what's going on, right? Between the first quartile and the third quartile. You're cutting out those potentially extreme values and you're just looking at, okay, where's the central 50%? It's between, or it's in this range, right? It has a distance of 2.5 between it. So that's how it's a measure of spread. So how about the same thing, the interquartile range with 8 data points. IQR is still Q3 minus Q1. You'll notice that I always write out the empty formula that I'm about to fill in. And that's just a good habit for you guys to get into or try to get into, right? Is just have that empty formula and then fill it in. It makes it easier for, well, just looking back at your work later on, but also for me to read through and I don't have to try to read your mind what you were doing, right? So if you had Q3 is 3.45. Minus 1.6 again. Oops. 1.85. So just less spread in this distribution, which we know because we took out a big data point, right? Size doesn't matter, but we took out a data point, right? So those are your interquartile ranges. Okay. You'll notice on the assignment, I'm asking for, so 2A and 2B, I ask for the 5 number summaries. Okay. So the 5 number summaries, what part was this? Does anyone remember? In my fake, yeah, let's make it E then. Part E. Find the 5 number summaries, or 5 number summary of the data. The 5 number summary is the minimum, right? That one's easy to find. It's the smallest value, right? And then it's the first quartile, it's the median, the third quartile, and then the maximum. Okay. So 5 number summary is the minimum, Q1, the median, Q3, and the maximum. Let's just do it for 9 data points. What did we have? I like to do the minimum and the maximum right away. Right. It's easy. We've already sorted it, right? So 0.5 and 7.1. Q1 was 1.6. The median is 2.8, and the third quartile is 4.1. 1.6, 2.8, and 4.1. So the 5-number summary is supposed to help us see what's going on in the data. It's really hard, or at least I have a hard time looking at these values and going, oh, the distance between these two is way more than these two, for example, right? So it's hard for me to look at just data points in a row and figure out the distance between them. Right? And so that's why we visualize the 5-number summary with a box plot. But before we can draw a proper box plot, we need to figure out if there's any outliers. Okay? And so part C, does it contain any outliers? Right, so a follow-up question. Does the data contain any outliers? Or I'll just say, because I already said it. Does the data contain any outliers? Right. Or I could even ask something as simple as, are there any outliers? So for outliers, right, outliers are these extreme values. And yeah, we can look at data, right? We'll just use the 9 data points. Let's keep it here. Copy. There. We can look at this and say, well, 0.5 looks a little small, right? But also 7.1 looks a little bit big in comparison to all these other values, right? So they might be considered outliers. But we need some sort of threshold to say, if it's larger than this value, right? Or if it's smaller than this value, they will be considered outliers, right? So we need some sort of rule to say anything beyond these 2 points, right? Because we could have outliers on the lower end or on the upper end, right? Anything beyond these points is going to be considered an outlier, right? And that's how we'll figure out if there are any outliers, or if there are, how many are there. And so to find outliers, we use the 1.5 IQR rule. Kind of weird name for a rule, right? But what we do is we take the interquartile range, right, which we found, the distance between Q3 and Q1, we multiply it by 1.5, and then that distance down from Q1 would be your lower bound, and that same distance up from Q3, right, so you're going from Q1 and Q3 is going to be considered an outlier. Okay. So probably easier to just display it in math. So what we do is we have a lower bound is Q1 minus 1.5 times the interquartile range. And then the upper bound is Q3 plus, right? Now, so from Q3, we're going up 1.5 times the interquartile range. So a question that I get pretty often is, why is it 1.5? And so of course I've said, I don't know, some people got together and decided that that was a good number. There's lots of rules that you could use, depending on how strict or how lenient you want to be on your outliers. But the guy who came up with the 1.5 IQR rule, his name's Tukey, can't remember his first name, John Tukey, I think. And I guess someone asked him, so why'd you pick 1.5? He was like, 1 was too small and 2 was too big. Okay, 1.5 it is. So there's no real rhyme or reason. It's the rule that we'll use. It's kind of widely accepted as a good rule of thumb for finding outliers. Okay. So any values beyond these bounds will be considered outliers. So let's find if we have any outliers. Now, I'm just talking about the 9 data points at the original data set. The method would be the same for the 8 points. So now, if we have to find the lower bound, Q1 was 1.6, right? And we found our interquartile range to be 2.5. Right? I'll just say, recall the interquartile range is 2.5. Usually you would have calculated the interquartile range, but it's just quick. Right? So the lower bound, got sloppy, is Q1 minus 1.5 times the interquartile range. Q1 is 1.6 minus 1.5 times 2.5. 1.5 times 2.5 is 3.75. So 1.6 minus 3.75, negative 2.15. Any value smaller than negative 2.15 would be considered an outlier. Right? We don't have any values that are smaller than that. Just looking at the minimum is 0.5. There are no smaller values than the minimum, right? And so since the minimum of 0.5 is within this bound, right, we don't have any outliers on the lower end. So since the minimum of 0.5 is within this lower bound, there are no outliers on the lower end. How about the upper bound? The upper bound is Q3 plus 1.5 times the interquartile range. Q3 was what? 4.1. 4.1, we can go up 1.5 times the interquartile range. So 4.1 plus 3.75. 7.85. Sometimes when values are close like this, you'll have your data sorted, right? So then, sometimes it makes it easier if I just draw in some bounds here. Negative 2.15 is the lower bound. And here, 7.1, because 7.1 and whatever we found, 7.85, they're pretty close, right? But if we have to kind of visualize it and put 7.85 on here, oops, it would go somewhere here, somewhere beyond 7.1. So because these bounds are around all our data, we don't have any outliers. And so if we had a data point that was beyond here, right, 7.85, let's say we had a data point of 8, right, that would be considered an outlier. So we have to explain what's going on. Right? And I think I even said that, oh yeah, justify your answer with an explanation, right? So you can't just go ahead and do these calculations and say, no, there are no outliers. You have to tell me why, or why there are or why there aren't. Right? So since the maximum of 7.1 is within the upper bound, there are no outliers on the upper end. Therefore, there are no outliers. One thing, F, G. So there we found if there are outliers. So one thing that I'll get you to do, so there's a couple of quick sketches that we'll do, which I'm kind of opposed to making you do, but we have to make you do them. Anyways, one is the stem and leaf plot. The other is this box plot. So you're expected to know how to draw a box plot by hand. Of course, I'll show you how to do it in the lab, right? But we'll draw a quick box plot. Helps to know what's going on. So draw a box plot of the data. So a box plot is a visualization of the 5-number summary. So a box plot is a visualization of the 5-number summary. Oops. So there's 2 ways that we can draw them. Okay. I'll draw one out and then I'll tell you kind of the anatomy of it. Okay. As you might suspect, there's a box. Starts with a box. Okay. A box with a line in the middle. The line in the middle is the median. The lower line of the box is your Q1, and the upper line is your Q3. So far, so good. Right. Assuming that you have some scale on this side. So, first step is draw a line at the median. Second step, draw lines at Q1 and Q3. Connect these to make a box. Third step, I'll scoot it over here. You're going to draw what's called the whiskers. So the whiskers look like this. So it's just a line down in the center and then a smaller line to show, and the whisker, yeah. Would it be wrong if it was like this? Yeah. I'll do that one too. Okay. Yeah. And actually, for drawing it by hand, yeah, I would say go like this. It's just because so when we do it in software, when we make a box plot in software, it turns out like this, but I'll show you how to tip it, and it makes it a little bit easier for drawing it by hand. Thank you. Good point. So, but part 3, so the parts all stay the same, it's just which axes do we draw it on. Part 3 is draw the whisker. The whisker is either going to go to the smallest value within the lower bound, right, or to the minimum, whichever comes first, right? So in our case, right, the minimum is within the lower bound. So then we just draw it to the minimum. Okay. So draw the lower whisker to the smallest value within the lower bound. So if the minimum is within the lower bound, then you draw the whisker to the minimum. I'll put minimum there. If there's an outlier, then you indicate it with just a star for each outlier. Okay. So if there are outliers, indicate them with individual stars beyond the whisker. Goes for the lower bound and the upper bound, of course. Step 5, draw the upper whisker to the largest value, within the upper bound. So just as an example, of what it would look like if you have an outlier. You would draw it with just a star. If each of these sections is roughly the same size, then we have a normal distribution, right? So if it's cut up, right, and each of the sections are, or if it's symmetric, I should say. So if the box plot is symmetric about the median, the distribution is normal. It's not something that I would get you to do, but it's good to know. Like I said, for drawing it by hand, so for drawing box plots by hand, it might be easier to just tilt it on the other axes, right? So for drawing box plots by hand, it might be easier to draw it on the x-axis. So if you have something that starts here at 0, and then we do 1, 2, 3, 4, 5, 6, 7. Just roughly. Right. If I'm getting you to draw a box plot, I would give you the axes, right? So you don't have to figure out where they are. Okay. So for us, right, what was our 5-number summary? I'll sneak it. It was a long time ago. Just kind of stealing this from here. Just put it down here. So I like to start at the median, 2.8. Right, if we're gonna flip it, the median would be here at 2.8, roughly. Q1 is at 1.6. 1.6 would be somewhere midpoint here between 1 and 2. 4.1, somewhere close to 4. So first step, draw the line for the median, then Q1, then Q3, or vice versa. Connect these to make a box. And then, if you wanted to, you could draw these bounds on here kind of temporarily, right? Because your whisker is going to go to the smallest or the largest value within those bounds. But for us, we've already done that work, so we've got a minimum at 0.5. Notice that that whisker has a shorter bar connected in the middle, and then 7.1. So we've got a quarter of our data, right? because we don't have any outliers. A quarter of our data in this distance, a quarter of our data in this distance. Right, so up to this point, we've already covered 50% of our data. Then it's going to take us a little bit longer to cover another 25%, and then a long time until we reach that last quarter, right? Meaning, right, it looks like there's less data here, but if it's nice and tight like this, it means that we have a lot of data in there, right? Because it only took us that short amount of time to cover 25% of it. So if you had to kind of figure out what's going on here, right, we would have the first half of our data somewhere here, so it would be kind of a big bulb, and then it would kind of smooth out, and then we would have this tail here. Great. So that's how you draw a box plot. I've got just 2 minutes. You know what? We'll do 1.7 next day. It's just brief, and it does lead us into chapter 2. But you have everything that you need to do assignment 1. And like I said, if you didn't get a copy, then just kind of hang back. I'll run upstairs, get some copies, get them to you. All right. See you guys on, well, I guess Friday if you're coming to the lab on Friday, but otherwise on Monday. Yes.
Can I ask you a couple of questions about the assignment?
You bet.